Hello student. So let us start with electronics paper 1, applied electronics. So we are already started with chapter number 4, operational amplifier. This is second lecture. In first lecture we have seen what do you mean by amplifier, what do you mean by operational amplifier. Then we have seen the block diagram of operational amplifier. Then we have seen the pin diagram of operational amplifier, the schematic symbol of operational amplifier, right? It has two inputs, one output and two power supply. It works on a dual power supply, right? Plus and minus, and two inputs, they were named as inverting terminal and non-inverting terminal, and we have seen why they are called as inverting terminal and non-inverting terminal in our last lecture. So let us start with the second lecture. So before we see the characteristics of op-amp, let us see the equivalent circuit of op-amp. So this is the equivalent circuit of op-amp. So as you can see here student, this is Ri is the input impedance of this op-amp. Likewise, this Ro is the represents the output impedance of this op-amp. The output voltage of the op-amp will be the open loop gain A, that is open loop gain, multiplied by the difference between the input signal, that is V1 and V2, that is nothing but Vd. So now before we see the different characteristics of the op-amp, let us see the different characteristics of an ideal op-amp. What I say? Before seeing the different characteristics of op-amp, let us see the ideal characteristics of an op-amp. See, ideal characteristics means it should have these characteristics, but practical it may vary, right? So that is the difference between the characteristics of an ideal op-amp and characteristics of an op-amp, right? So the ideal op-amp should have this input impedance that is equals to infinity. So Ri should be equals to infinity, so that whatever input that is been applied between the input terminal will directly get applied to the op-amp. So there will be no drop across Ri. So Ri should be infinity. Similarly, the output impedance, this is output impedance of this op-amp, should be equals to 0. That means whenever we are applying the output load to this, whenever we are applying, see we are applying the load to this op-amp, then the output voltage should directly come across this output load. So there should be no drop across this output impedance of the op-amp. Then if you can see the bandwidth, so this is nothing but the input impedance should be infinity and output impedance should be 0. Is it clear? There should be no drop across this impedance, internal impedance of the op-amp. That are the two characteristics. The input impedance should be infinite and the output impedance should be 0. Clear? The next characteristics, then if you see the bandwidth of the ideal op-amp, the bandwidth of an ideal op-amp should be equals to infinity. Okay, so bandwidth should be infinity. What is the bandwidth? Bandwidth is nothing but the range of frequency. So it means that it should support all the frequencies starting from 0 Hz to the infinite. So it should respond to all the frequency from 0 Hz to infinity. Okay, so bandwidth should be infinity of an ideal op-amp. This is another characteristics of an ideal op-amp. Similarly, the gain of the ideal op-amp should be equals to infinity. So open loop gain of the amplifier should be equals to infinity. So we have seen the 4 characteristics, this that the input impedance should be infinity, output impedance should be 0. The bandwidth should be infinity, means it should respond to all the frequencies, right? And the open loop gain should be infinity. What is gain? Output upon input. Output voltage upon input is a nothing but gain A. So the open loop gain should be infinity. So apart from whatever these two inputs, whenever these two inputs terminal are 0, that means the input to this op-amp is 0. At that time, the output of this ideal op-amp should be equals to 0. Obviously, when there is no input, the output should be equals to 0. So when we are not, when the input is 0, the output should be 0. Output voltage should be 0. That is the next characteristics of the op-amp. Now apart from these characteristics, there are few more characteristics. The ideal op-amp, that is slew rate and common mode rejection ratio. We will see more about this different characteristics in detail in next lecture. But let us see the basic of this different characteristics. So in a simple way, if I say that the slew rate is the basically how fast the op-amp is able to reach its final value is in that in particularly useful when we apply a square wave, when we are applying a square wave to the op-amp. So let us say we have applied a square wave at the input of this op-amp. At the output we will be getting a waveform that is varying from 0 to the saturation voltage. So the ideal op-amp should be able to reach from 0 volt to the saturation volt in 0 time. So as soon as we apply, so the output should reach from 0 to the saturation voltage very fast. So for the ideal op-amp, the slew rate should be equals to infinity. This slew rate is defined as maximum rate of change of output voltage with respect to time, and it is given by the unit of the slew rate is volts per microsecond, and that means how fast the op-amp is able to respond to the output voltage, right? So that is nothing but slew rate. Then there is another parameter which is known as common mode rejection ratio. So let us understand this in very brief. About this CMRR, we will see this in detail in upcoming lectures. So let us say if we are applying same input voltage to the two V1 and V2, that the difference between the two input will be equals to 0. If I apply same input, अगर V1 और V2 को same input apply किया, तो V1 minus V2 will be naturally equals to 0, and therefore the output will be 0. Likewise, when we are applying the different input voltages, then the difference between these two input will get amplified by the certain amplifier gain, and so the common mode rejection ratio is basically defined as how well is op-amp able to reject the common input voltage that is been applied to this both of the input. So when we are applying the common, see when we are not applying anything but still there is some error voltage at the input, and this get amplified at the output. So this common mode input should be rejected. So how the op-amp is able to reject this common input voltage that are being applied to the input terminal, and how well it is amplified, right? So that is nothing but how well able to reject this common input voltage that is being applied to both of its input terminal, and how well it is able to amplify the difference between this. So in general it is defined as the differential gain to the common mode gain. Okay, so common mode rejection ratio is defined as the ratio of differential gain to the common mode gain. So for an ideal op-amp, the value of this common mode rejection ratio should be equals to infinity. So when a common voltage is get applied, the noise or electromagnetic interference, and at the output it gets amplified. So to reject this, that is nothing but common mode rejection ratio. Okay, to suppress the common mode input voltage, the that is nothing but CMRR. So we have seen the characteristics of the op-amp. So here is the list of different ideal op-amp characteristics. So the ideal op-amp has infinite input impedance. So Ri is infinite. The output impedance and infinite open loop gain and infinite slew rate and bandwidth, right? And in this ideal op-amp, whenever the input is equals to 0, the output should be equals to 0, also 0. And this ideal op-amp has infinite common mode rejection ratio. But if you see any practical op-amp, they used to have infinite input as well as output impedance. Generally, the input impedance is in the range of mega ohm. So the input impedance of the practical op-amp is in the range of mega ohms, while the output impedance is in the range of few ohms. Okay, few ohms. Similarly, the open loop gain of the op-amp is not infinity, but it used to be in the range of 10 raised to 5 to 10 raised to power of 6. Likewise, for the practical op-amp, when the input is equals to 0, the output at that time also you will get some output at the op-amp. Generally in, in the range of few millivolts. That is known as offset voltage. That is nothing but offset voltage. We will see more about this in upcoming lecture. So here is a list of different parameters and values of different parameter for a general purpose 74 op-amp IC. So ideal characteristics of op-amp are this, and this is nothing but general practical op-amp IC. Okay. So these are the specification for the practical IC, right? So student, in exam question comes for 3 marks, state the ideal characteristics of op-amp. Clear? So you have to state the ideal characteristics of op-amp. These are the ideal characteristics of op-amp. So now if you see the different op-amp ICs, they are optimized for different parameters. So let us see if one op-amp is optimized for high slew rate while the other is optimized for high open loop gain. And if you see some other IC, you might find that it is optimized to very low offset voltage. So depending upon your application, you need to decide which parameter is critical for your application. So what parameter is critical? Upon that you can select the IC. Based on that, you can decide which op-amp is suitable for your particular application. Now, so far we have seen this op-amp in open loop configuration, that is no feedback was given from output to the input, right? This in next lecture we will see what happens when the feedback is given, right? So let us see the parameter of the 74 IC. So specification. So when we are doing the practicals, you need to write the specification of op-amp IC. So parameters: input impedance is 2 mega ohms, output impedance is 75 ohms, open loop gain is 10 raised to 5 to 10 raised to 6 ohms. Then offset voltage is 1 millivolts, slew rate is zero point 0.5 volts per microsecond, and CMMR is 70 to 90 decibels. It is measured in decibels. Let us see the parameters of op-amp. The parameters of an op-amp are input bias current, input offset voltage, input offset current, common mode rejection ratio, slew rate, open loop gain, closed loop gain and frequency response. So we'll see the parameters of an op-amp in detail. Student, question comes on parameters of op-amp. To explain the parameters, any three parameters of the op-amp. Clear? Let us see each parameter in detail. First parameter is input bias current IB. So far we assume that the op-amp is an ideal op-amp. That means no current is flowing in the op-amp terminals. But actually, if you see, whenever the biasing voltage are applied, see we are applying the biasing voltage, that is VCC and minus VEE are applied to the op-amp, small amount of current used to flow into the input terminal. So the current are known as input biasing current. This current is known as input biasing current. Current flowing through the non-inverting terminal is IB plus, and current flowing through the inverting terminal is IB minus. So here IB plus and IB minus when we are applying the biasing voltage. Internally, these currents are flowing through the transistor of the differential amplifier. So internally, if you see the internal circuit is a differential amplifier, so they are flowing through the transistor. These are the base current of transistor. So these are nothing but the base to the two base of the two transistor. The biasing current is defined as the average value of the biasing current of inverting and non-inverting inputs of op-amp. So it is given as IB is equals to IB plus IB minus upon 2. Ideally, these two biasing current should be identically. Actually, these two biasing should be identically. Because of some mismatch between the two transistors, there will be some difference between the two biasing currents. Generally, so there is slight difference between the two input transistor. Inverting input biasing current is not equals to the not inverting biasing current. General purpose op-amp, this input bias current used to be in the range of nano amperes. So it is in the range of nano ampere for the practical circuit, right? So that is nothing but input bias current. Student, you have to draw the diagram and the formula. You have to write the formula. If it is asked, explain the input biasing current of the op-amp, right? So you have to draw the diagram and define what do you mean by input biasing current. It is nothing but the average value of biasing current of the inverting and non-inverting input of the op-amp. Okay, that is IB is equals to IB plus absolute value of IB plus IB minus upon 2. Clear? The next parameter is input offset current, that is IOS. It is defined as a difference between the biasing current of inverting and non-inverting inputs of operational amplifier. IOS is equals to IB plus minus IB minus. So it is the difference between the two biasing currents, right? It should be equals to 0, but it is measure of mismatch of the input of the transistor. But the transistors are not equal. There is some mismatch, and therefore we get an input offset current, right? So these currents are flowing through from the transistor base of the transistor of a differential amplifier. The next parameter is output offset voltage VOO. When the input voltage to an op-amp are 0, so when we are applying the input, that is inverting and non-inverting terminal are grounded, the output must be 0. Ideally speaking, it should be 0. But due to some error, the output voltage is other than 0. So this error voltage in the output is called as output offset voltage, right? So due to some error, the ideally speaking, the output voltage should be 0 when we are applying 0 volt at the input terminals, but there is some voltage and this error voltage is called as offset null offset output offset voltage, right? So the voltage which appear at the output when no inputs are applied, that voltage will be called as output offset voltage. In today's lecture, we have seen the characteristics of an ideal op-amp, then the characteristics of the practical op-amp. Then we have seen the parameters of op-amp. We have seen the half parameters, that is input bias current, then out input offset current, and we have seen the output offset voltage. So the remaining parameters we'll see in the next lecture. So here we came to the end of operational amplifier session second. Okay, thank you.